Hi, welcome to this video. In this video, we are going to discuss the therapeutic equipments. The code is CBM 368. In this subject, the first unit cardiac and respiratory therapy equipments. In the first unit, the main aim is to gain the knowledge on the working of therapeutic body care equipments and suggest the suitable devices for ailments related to the cardiology. The first topic is cardiac pacemaker. Before going to see the pacemaker in detail, why we need this pacemaker? The rhythmic beating of the heart is due to the triggering pulses that originate in an area of specialized tissue in the right atrium of the heart. This area is known as sinoatrial node. In abnormal situation, if this pacemaker ceases to function or becomes unreliable, or if the triggering pulse does not reach the heart muscle because of blocking by damaged tissues, the natural and normal synchronization of the heart action gets disturbed. When monitored, this manifests itself through a decrease in the heart rate and changes in the ECG waveform. So, by giving a external electrical stimulation impulses to the heart muscle, it is possible to regulate the heart rate. So, these impulses are given by an electronic instrument called the pacemaker. So, with the help of an electronic instrument, we can control or we can regulate the heart. So, the classification of pacemakers into different types, it is based on the mode of application of the stimulating pulses to the heart. That is internal pacemakers and the external pacemakers. When you go for external pacemakers, it is used when the heart block presents as an emergency and when it is expected to be present for a short time. When you go for internal pacemakers are used in cases requiring a long-term pacing because of permanent damage that prevents normal self-triggering of the heart. So, in the later case, the pacemaker itself may be implanted in the body. So, the patient is able to move about freely and it is not tied to any external apparatus. So, this is a functional block diagram of the pacemaker. It is having a sense amplifier, timing control, and there is one output driver. The overall is connected to the power source and the output of the driver is connected to the electrodes, and once again it is a feedback into the sense amplifier. So, let us see first one, external pacemaker. So, the external pacemaker are employed to restore the normal rhythm of the heart in case of cardiac standstill. In situations where short-term pacing is considered adequate while the patient is in the IC unit or it is awaiting an implantation of the permanent pacemaker. So, the pacing impulse is applied through a metal electrodes placed on the surface of the body. So, electrical electrode jelly is also used for better contact and to avoid the burning of the skin underneath. An external pacemaker may apply up to 80 milliamps pulses through 50 cm square electrode on the chest. This procedure is painful and therefore used only in the emergency or temporary situation. So, the pulses may be delivered on continuously or on demand of R-wave synchronous pacing. So, when you go for continuously, when it is felt that the heart rate is below the preset value, the impulse frequency is independent of the electrical activity of the heart. When you go for next one, on demand of R-wave synchronous pacing, this is a on demand of R-wave synchronous pacing. Normally the pacemaker is inoperative, but it is activated when the heart rate falls below the normal or preset value. In such a situation, beat to beat examination of the time interval between two R-wave is done. When this interval exceeds the preset value, the pacemaker comes into the operation. This technique eliminates any competition between heart's own pacemaker and the externally applied pacemaker pulses. So, in the pacemaker, external pacemaker, pacing with the external pacemakers through the chest requires maximum of 150 pulses across an impedance of order 1 kilo ohms. However, external pacing has the disadvantage. Kindly note down, when that is the electrode eventually tend to burn the skin and the electrical pulses become painful. When you go for external pacemakers, so these are all the points to be noted down. So this is a block diagram of the external pacemaker. So the electronic circuit of the pacemaker consists of two parts: oscillator, that is impulse generating oscillator circuit, and the output circuit. The impulse forming circuit determines the frequency and the duration of the impulses. This is usually a multi-vibrator circuit with adjustable rate and the fixed pulse width, whereas in the output circuit determines the shape and amplitude of the pulses. So there are three types of pacemakers used in the output waveform. In the type of output waveform, one is a voltage pacemakers, another one is a current pacemakers, next one is your current limited voltage pacemakers. When you go for voltage pacemakers, it is those in which the current in the circuit is determined by the available voltage during the entire duration of the impulse. So the voltage output from the pacemaker remains constant, and changes of resistance in the circuit will influence only the current. Coming to the current pacemakers, so in the second class, throughout the impulse, the current in the circuit is determined by the internal resistance of the pacemaker. When you go for last one, current limited voltage pacemakers, so this is a primarily voltage circuit, but the maximum current in the circuit is limited, preventing too large a current impulse to circulate when there is a low resistance in the electrode circuit. With these pacemakers, during the first part of the impulse, the current in the circuit is determined by the internal resistance of the pacemaker. But during the second part of the impulse, current in the circuit is determined by the voltage available, that is constant voltage version. So coming to next part, implantable pacemakers and programmable pacemakers. Let us see first one, implantable pacemakers. This one is along with the electrodes, it is designed to be entirely implanted beneath the skin. Its output leads are connected directly to the heart muscle. So the pacemaker is a miniature pulse generator and is powered by a small batteries inside the pacemaker, inside the device. The circuit is so designed that the battery supply is sufficient for the long period. Since the pacemaker is located inside the beneath the skin, the replacement of the pacemaker unit involving relative to the minor injury, and it is a routine procedure. Okay, so for the implantable circuit, the basic requirements for this are, the first one is components used in the circuit should be highly reliable. Next one, the power source inside the devices should be a position to supply sufficient power to the circuit over a very long period of time. And the next one, the circuit should be covered with the biological inert material so that the implant is not rejected by the body. The final one is very important. The unit should be covered in such a way that body fluids do not find a way inside the circuit, and it leads to batteries, that is a short circuit the batteries, or sometimes a malfunctioning of the circuit. So there are three basic types of implantable pacemakers: single chamber pacemaker, dual chamber pacemaker, rate responsive pacemaker. When you go for the single chamber pacemaker, in a single chamber pacemaker, only one wire is placed into a chamber of the heart. Sometimes it is upper chamber or atrium, other times it is a lower chamber or ventricle. Coming to the dual chamber pacemaker, in dual chamber type, wires are placed in two chambers of the heart. One lead passes the atrium and one passes the ventricle. This approach more closely matches the natural pacing of the heart. This type of pacemaker can coordinate function between atria and the ventricle. Rate responsive pacemakers, last one, these have sensors that automatically adjust to change in a person's physical activity. So this is a implantable pacemakers, various pacing modalities in a demand pacemakers. Sometimes another type of implantable pacemakers are also available: fixed rate pacemakers, demand pacemakers, R-wave triggered pacemaker, ventricular inhibited, atrial triggered, and dual chamber. Dual chamber already we have seen, and let us see one by one. In the fixed rate pacemaker, this type of pacemaker is intended for patients having permanent heart block. The rate is preset, say for example 70 BPM. The rate can be varied externally in implanted units by magnetically actuating, there is one built-in relay. Coming to demand pacemakers, These pacemakers have gradually almost replaced the fixed rate pacemakers because they avoid the competition between heart natural rhythm and the pacemaker rhythm. The demand unit functions only when the RR intervals of the natural rhythm exceed the preset limit. Coming to the next one, R wave triggered pacemaker. The ventricular synchronized demand type, that is R wave triggered pacemaker, is meant for patients who are generally in a